Hello everyone. Today we're going to learn about maximum and minimum values. Okay, as implies from the wording here, maximum and minimum value, you know what is it, right? Okay, at least I hope you know what it means. Maximum and minimum values, but this is we are going to learn from a math point of view. Okay, so for example, a function f has an absolute minimum at c. I don't know. Okay, this to make it simpler for you, okay, this sentence here can be simplified into, I don't like long sentences too in maths. It doesn't make sense to me. So what does it mean here is when x equal to c resulted in maximum value of the value of f, in maximum value of f. So when x equal to c, f is at its maximum value. So what does it mean by absolute minimum? Absolute minimum is the opposite to absolute maximum. Okay, absolute minimum is when x equal to c, it will result in minimum value of the function f. Okay, so the maximum and minimum values of x are called the extreme values of f. Okay, so now what is a local maximum? Okay, I think it's better. Local maximum is also can be termed as relative maximum, as well as local minimum can be termed as relative minimum. Okay, let's say here we have this function. Okay, so this is the absolute max, right? Absolute maximum value for this function f, and here is the local maximum because it is near in value with the absolute maximum. Okay, this one is near to, right? Okay, so for minimum here, so minimum, which one is the lowest? I think the lowest here is, so this should be the absolute minimum, and this part here and this part here can be termed as the relative minimum, right? Okay, so this is relative maximum. Okay, so local maximum and a local minimum can also be termed as a value that nearly reaches the max or minimum value, right? Okay, so now let's look at example 4. Example 4 wants us to find the local minimum and maximum, and also the absolute minimum and maximum. So whenever you think local is the almost almost there, okay? Almost there, but not quite reach it. And this absolute means it is the highest or the lowest, right? Okay, so now, looking at this graph, which one do you think is the local minimum? Local minimum is when x equal to what? Local minimum is when x equal to C and E. Okay, forgot to tell you, the local minimum can also be the absolute minimum. Okay, it can be the same thing. Okay, so x at C and x at E. Local maximum, local minimum can be many points, but for absolute it must be only 1 point. So local maximum, which one do you think? It should be B and D. Okay, so now which one is the absolute minimum? When x equal to what? The absolute one. The lowest point is when x equal to which one? I think it is E, right? And absolute maximum is when x equal to, the highest point is when x equal to D. Okay? Okay, so moving on to the next slides. Okay, extreme value theorem. What does it mean here is the maximum and minimum value can only be determined on a function that is continuous. If the function is not continuous, there should be no maximum or minimum value. Okay, so now let's look at example 5. So in example 5, we want to find the extreme value for each function. So look at function 1 here. What is the absolute maximum here, do you think? Okay, when x equal to absolute maximum. Absolute maximum, oh my gosh, it's so hard to see. Which one do you think? I think it is D. Okay, and absolute minimum, okay, easy, right? It's clear cut. When x equal to C. Now looking at example 2, which one do you think is the absolute maximum? Is it here? No, it is this function cannot be termed, we cannot find absolute maximum or absolute minimum value in this function because this function is not continuous. It is breaking at point B, right? So I'm going to write it down in case you did not really grasp what I said. So absolute maximum and absolute minimum does not exist because the function is not continuous. Okay, so now looking at example 3, so absolute maximum is what? Do you think absolute maximum is when x equal to what, guys? A, B or C? It should be B, right? And absolute minimum is when x equal to C. Okay, so now we're going to move to the next slides. Okay, what does it mean here? A critical number of function f is a number C in the domain of f such that okay, I'll simplify it for you. Okay, value, what does it mean here is value of C. C is a critical number, right? Okay, value of C will resulted in f prime C. Value of C, C is critical number, don't forget. Okay, value of C will resulted in f prime C equal to 0 or f prime C does not exist. Okay, this is what it means by definition 4. So definition 5 says if f has a local maximum or minimum at C, then C is a critical number of f. Okay, I don't think I need to explain any further for you, okay, because it's pretty clear cut. Okay, so now we want to look at example 5. Okay, we try given y equal to x cube and y equal to modulus x, find the critical number in both function and sketch both function. Okay, we do it one by one. First, we do the y equal to x cube. Okay, y equal to x cube. So the dy, to find the critical number, we have to differentiate the function, right? So differentiate y dy dx should be 3x square. Okay, and we let it equal to 0 because we want to find the critical number, kan? Right? Okay. Okay, so now x equal to 0. So 0 is the critical number for y x cube. Okay, so this is the answer. Okay. Okay, now sketch function y x cube is, okay, function is should be like this, right? I'm pretty hopeless in sketching graph, but I try to do my best. Okay, something like this. Okay, so this is y x cube, and is there any local absolute maximum or minimum point here, do you think? No. We cannot. At x equal to 0, it is neither the local or absolute max or minimum point. Okay, so this is the final answer for 5a, y equal to x cube. So now we're going to solve this one here. Okay. Okay. Okay, so now y equal to modulus x. Okay, what does it mean here by modulus x is the value of y is equal to x if x larger than 0, 0 if x equal to 0 and minus x if x less than 0. So how to do the dy dx for this? How are we going to do? Just differentiate this part here lah, right? So differentiate x, you got 1. Differentiate 0, you got 0 also. Differentiate minus x, you should get minus 1. Okay? So, the critical number for this should be at x equal to 0. Let's see here. Okay. Okay, so this is, we want to sketch the function y equal to modulus x. Okay. When x equal to 0, this function becomes 0. F prime c becomes 0, right? So the critical number is when x equal to 0. And so we have sketched the function here. And the absolute minimum is when x equal to 0 as well. There is no absolute maximum here. Okay. So now, okay, let's see example 6. Okay. Quick reminder, what is a critical point? What is a critical point, guys? Critical points is the value or the numbers is the value that cause f prime x to be 0 or does not exist. Okay, let's look at example 6a. So 6a is this one, and we want to differentiate it. F prime x is what? Okay, 20x to the power of 4 over 5 minus 9x squared. Okay, and then you should equal this equation to 0, right? Because we want to find the value of x that will cause f prime x to be 0. Okay. Okay, 5 bring up here will be 0. So we have here 20x to the power of 4 minus 9x squared equal to 0. So put together x squared and minus 9, sorry, x squared 20 minus 20x squared minus 9 equal to 0. Okay, so now we have two equation here. X squared equal to 0. So x is 0, right? And another one here, 20x squared oh sorry, this is not 20, this is 4, my mistake. Okay, this one should be 4 because 20 over 5 is 4, right? Okay, so okay, 4x squared minus 9 equal to 0. Okay, and x should be 9 third 9 over 4. Okay, guys, can you get Did you get it? So the critical point for question 6a is 0 and third 9/4. There is two values. Okay, now we want to try to solve question 6a. Okay, question 6a. Okay. So fx here is x square. We can rewrite it like this, right? X plus 1 power to the power of half. Okay, looking at this equation, do you know which formula to use? We should use product rule because this is the multiplication of two functions. Okay, so u here is x square and u prime is 2x. And v is x plus 1 to the power of half, and v prime is half x plus 1 minus half. Okay, so f prime x is uv prime plus vu prime. Uv prime is x square or times with 2/3 x plus 1. 2x times with third x plus 1 to the power of half. So now we can use complex conjugate here. Okay, let me use another color. Okay, we use complex conjugate. So this is over 1, and then I hope you can see this. Okay. Okay. So then you will have x square plus 4 plus 4x okay. Then simplify it. Equal to 0. Oh, it's not finished. Okay. Can you do this on your own? Or I don't know whether you can do this on your own or not. I think I have to help you guys with this. So let me erase something first. Sorry, I'll be talking to myself again. Okay. So for question example 6b, there is what I do just now is I equal to 0 this upper part and lower part here, and for the upper part we have x equal to 0 and x equal to minus 4/5. Okay, and for the lower part here we have x equal to minus 1. So for question 6b, there is 3 critical points, which is -1, -4/5, and 0. So that concludes our lecture for today. Okay, see you guys.